In this video, we're going to look at the difference between quantitative and categorical data that we might collect. And some people have problems with deciphering between these two. What I will tell you is that in the real world, you can always have the ability whenever, and this is true about most everything, if you're in the world of dealing with data, you can always go back and look these things up. Although once you kind of get it figured out, hopefully it'll stick pretty good. But you can most definitely go to a Google search on this. Or whatever your favorite search engine is, and then look at, I actually encourage you to look at images, and actually instead of definitions, because when you click on images, it actually has a lot of examples of charts, whatnot, that can break this down for you even further than what I'm doing here. A lot of what you're going to be seeing is repetition though. So to start with, quantitative data, namely the idea here is this is something that we can count in terms of there's some type of measurement involved. So for instance, the number of students in a class, the population of a city, the age of an individual, height of an individual, the weight, things like that. Those are all quantitative pieces. They're measurements of some sort, as opposed to a category, which would be like a zip code, race, an age group. Now this is an interesting one to compare here versus age of an individual versus an age group. An age group is talking about a group of people as opposed to individuals. You're measuring the age of the individual. Here you're talking about somebody is in a category of between 40 and 50 or between 50 and 60 or whatever that group is. Same thing with the race is the idea that that is a group of people. When we talk about ethnicity and race and all these other different ways that we can describe this particular piece, it's talking about a group of people. And we're going to look at some graphs here in a moment that kind of maybe emphasize this a little bit better. It's just a matter of which one you're dealing with. When you talk about zip codes, yes, that is most definitely a number. It's a numerical value, but it is not quantitative. It is categorical because it talks about a group of people or a group of individuals. Remembering individuals don't necessarily have to be people. We might talk about state parks would be another way to talk about the zip codes, or national parks. That would be maybe your individuals or trees in those regions, or a particular animal or plant or whatever in that area, as opposed to a population in the city, or the number of rats in the city, or the number of dogs in the city, versus the state or the state national state parks versus the national parks. So you're talking about being able to clump groups of people or things or items together here, as opposed to counting a particular value here with the quantitative value. Here I have sex, which is a binary piece. I don't mean to be offensive, although some people are definitely going to take issue with the way I define that. It's simply a binary piece, and a lot of times when we deal with data, it is the most useful and descriptive piece. And this is not a social implication. This is not a social discussion. This is not a religious discussion. We all have our viewpoints on those politically, religiously, and every other way. This is a male-female. When we talk about a lot of particular aspects of data collection, that is an extremely useful piece right there. We start getting into the other categories, and it really changes things a lot. But if you're talking about in the medical world, there are definite differences medically if you're dealing with a male or a female, and that describes 99.9% of the population, regardless of their any other things you can make about the groups. That describes almost everything you need to know about those from a medical perspective, which is why that piece of data is still collected as it is by most institutions. Eye color is another one. Natural eye color is another way that we can group people together. And both of these lists go on and on for a very long time without a whole lot of stop to them. So the idea being is that quantitative data is data that we can count, like the population of a city, versus a zip code would be we're grouping a particular population into an area. Does that area have particular characteristics in of itself? So quantitatively, we can compare, say, the year versus the population of a city. So the population of the city is going up, then it goes down, and then it goes back up, and it looks like it's shooting up. So that could be the population of the city, the world, whatever. And you can talk about what happened with this dip, or why is it going up? Are there economical implications thereof? But that's just the representation of that. And then also we can graph categorical information. Let's say this is the fern plants ownership, and this is by race. So we're looking why you would want this information. I have no idea, but there might be some linkage here. There have been some really interesting linkages in the past when you start looking at overall health of certain individuals. Are fern plants associated with better overall mental health? That's an interesting question. Actually caring for a plant, ferns are fairly difficult to care for in some respects. So having the ability to care for a fern might be an indicator of overall health. Not that one causes the other, but maybe that you have the time to take care of the fern plant means that you have the time to take care of other things as well. So there may be implications. And keep in mind that all this is made up. I'm not making, none of this is based on reality right here. These are just examples for us to look at. So we have our different groups here, and whatever these designations are, we could have called them 1, 2, and 3 instead of whatever they be. We just go group 1, group 2, group 3, and group 4. And group 1s, 2, 3, and 4 are associated with a particular race or ethnicity or whatever category we want that to be. Maybe it's zip code. Maybe it is region of the country. However we want to deal with that. And then the other value is keeping track of plant ownership. Now, the way we can look at this, instead of just being what is right now as a scatter plot, is we can come through and we can build a bar graph. By another name, we could also talk about this being a histogram, and there is a mild difference between these definitions. Right? So there is our bar graph. Not extraordinarily well done, but oh well. And the bar graph makes a lot of sense for this one. All right. There are other things we do, like a pie chart or circle graph, however you want to describe that. I'm not really terribly a big fan of those for lots of reasons, one of which is that you have to do a lot of pre-measurements and figuring out, like for instance in this case right here, we don't have any numbers attached here with any of this stuff. You can tell me that group 4 has the highest plant ownership, followed by group 2 having the second highest plant ownership. If I were to draw that out in a pie chart, I'd need actual numbers to be able to figure that out, because I mean, is this 50% of the group, or is this 30% of the group? I mean, what does this look like? Because even if it being 30%, that would still mean that the other groups should all be less in terms of that, possibly. You know, how do we break this up so that would work out? We don't have those values, so we'd say one group is like this and one group's like that. So maybe here's group 1, group 2, say here 3 and 4. No, that's not right. This is 4. This would be 1. There we go. Had it backwards. Anyway, is that accurate? Is this group right here actually more than half the group? Does it have to be? So there's a lot of things that go along with bar graphs that sometimes just don't make a whole lot of sense for us, which is why I prefer histograms and bar graphs, because they are much easier to build, and then the information we get from them is quite useful as well. I mean, just going back and looking at this, what type of symmetry do we have? Well, we don't really have a whole lot. If anything, though, we could say that this is mildly skewed left. Remembering skewed left means that there is a larger span on the left than there is on the right. The span on the right would be smaller, with the mean or the median, however you're measuring this, being somewhere right there. So what does that mean when we start asking other questions about what's going on with this data set? So there's that piece. How do we pull that information out of this pie chart? That's a much weirder conversation to have. These pie charts are useful when you're talking about, say, a budget, because then it can give you a pretty good indication of where we're spending most of our money. But when you're talking about doing analysis, in-depth analysis over other things, bar charts make a lot more sense for us, which is why we're going to study almost exclusively on these things, because they give us so much more information about what we're dealing with. And if we have these actual accounts, we can actually make and we can figure out where the means and where the medians are of these values. And we can also get a pretty good idea of where the modes are for these different pieces as well, if we have it lined up like this. All right. So again, remember that we can have two types of data, categorical and quantitative. And we can graph both of them. All right. And also keep in mind, I could have switched these One of the things I didn't mention is the fact that normally this horizontal axis would be our independent axis, and this vertical axis would normally be our dependent axis. And that's almost a standard way of doing that. All right, thank you.